Hello, I'm very pleased to present this work about the visualization of ongoing malware. So my name is Jean-François Lalande, and this is a joint work with Mathieu Simon and Valérie Vietri-Mtong. So first, I want to introduce the goal of this work, and this work is about malware analysis. So what is malware analysis? When you think about malware analysis, you may think about two techniques: the static analysis and the dynamic analysis. Static analysis tries to understand what is happening inside the bytecode of an application. So you parse the bytecode, and then you may compute the control flow graph of the application. The goal is to understand the piece of code that concern the payload of the malware. So it's not easy to parse and to do static analysis. So on the contrary, you can do dynamic analysis. It's more simple. You execute the malware inside the smartphone. You may also use a sandbox like the Cuckoo sandbox. And these two techniques are used in the literature to do malware analysis. Why are you using these two techniques? It's because you want to do reverse engineering. You have a sample of a malware and you want to understand what is doing this sample. And to do that, you have two techniques. You can take the code and try to understand the code, or you can observe what is doing the malware when executed. We focus on this work on dynamic analysis. It means that we use some tools to get some information during an execution. And when you look at the literature, most of the time, the researcher give new outputs of their dynamic analysis. They collect some new information, but they don't work on visualizing. And we believe that visualization tools would help. And in our visualization tool, we want to put two things that will be useful for the investigator. We want to put the operating system level, meaning to be able to observe what the malware is doing into the operating system. And the second thing we want to put is the bytecode itself. And the combination of these two visualization parts will help the investigator to understand the sample he wants to study. So before moving to the visualization itself, I want to give you some insight about malware and also about the tools we use to collect information. Some example you can imagine about malware are the remote admin tools. So you have three samples here: Bad News, Drawing Kung Fu, Mazar. These samples are very well known and have been studied in the literature. They may obey to a remote server. They may be combined with, like for Mazar, it includes also a spyware part, meaning that it collects your data. So these are the example of remote admin tools. Another example is Wipe Blocker. So Wipe Blocker erases all the data of your smartphone. Another example you may know is Simple Locker. It's a well-known ransomware, so you know what is a ransomware. It encrypts your data, and at the end you get this kind of screen when you have a message that say, okay, you have to pay to get back your data. And for this example, the visualization we want to have is the following. We want to be able to see the files that are encrypted, and on the other part, we want to be able to see the part of the bytecode that is involved in the process of encryption. So the needs we have for the visualization is that we want to observe the system. We want to be able to see the files, the sockets. We want also to see the code. And we want also to see these things over time, meaning that it's not a static view, because the malware is processing, and we want to see the things happening during the time of execution. So we created a tool which is named GroDDViewer that answers this problem. So the name is related to Grod. Grod, it's a monkey, an intelligent monkey from the Marvel's comics. And it's a reference to the monkey of Google that is clicking everywhere on the screen. And the 2D is because we want that the tool shows the things dynamically, because we want to replay an experiment dynamically in the viewer. And the second D, it's because it's a dual view. You see at the same time the operating system level and the code level. Let's talk just a little bit of information about how we analyze the application to get some information before visualization. So it's based on GroDDViewer, another tool that is doing automatically the analysis. So we take the application and we compute some static information. So I will not enter into detail, but mainly we locate the payload and we compute the control flow graph. And with this information, we can then execute the application into a smartphone. So we push an application into a smartphone and then we execute it and we observe what is happening in the operating system of the smartphone, and we collect some logs. And at the same time, we collect other logs about the code to know what part of the code have been executed. And all these things at the end goes to the visualization. Let's go to the visualization now. So the result of the Blair information flow collection is the following. You obtain a graph that shows that a process, here Simple Locker, the ransomware we have seen before, is executing and writes some files. You see that Simple Locker will write this file. It will also communicate with Tor. Tor is the process to communicate anonymously on the internet. And this graph represents what the malware is doing at operating system level. So now we will go to the next part of this presentation. I want to show you short demos about 3 applications to make you understand what GroDDViewer is doing. So this is the same example as before, the Simple Locker malware. You see the application here on the process here. And on the right, you have the bytecode view. So you see the packages. You can open a package, go to see the classes, and inspect, for example, these classes and see what are the methods inside. And the ability of GroDDViewer is to replay what happened. So you can hit this play button, and then you see the interaction between the processes and the system. So at some point of this experiment, you will see that Simple Locker will interact with some files. So you see Simple Locker here is interacting with these files because it is encrypting the files. And you also see here the Tor process. It means that the Simple Locker malware is communicating with the Tor. So this view is very useful when you want to replay dynamically what Simple Locker is doing. And this graphic interface is also useful when you want to see what happened from the user perspective. I can see you in another example. So in this example, it's another application. It's com.tellmewhere. So you see that the graphs are very complex. So it becomes difficult to follow things. But another useful thing is that you can see what is happening from the user perspective. You see the different screens. You see the interactions that have been done to obtain these screens. And on the upper side, you can focus on a particular part of the malware. You can say, okay, I want to focus on what happened on this particular time interval, and then you can see the reduced graph for this part. And you can replay, as before, what happened during this part of the time. The last example I can show you, it's another example. It's a Mazar application. So it's a rat malware. And if you do the replay, with this button, you can see what is happening here. And if you look at the bytecode, you see here an highlight on this particular method, check device admin. And it's because the malware is asking for admin permission. And you see that the code of the real payload, the code is waiting that the user click on, okay, I give admin rights, and then the payload, which is located in these nodes in red, will be executed. But the malware requires to be admin. So this interface helps to investigate the execution from on the left side, the operating system level, or on the right side, the bytecode level. Let's go back to the presentation. As a conclusion, I want to say that you understood that the goal is to make easy the reverse and the investigation of an application, but of course it's not all the problems are not solved. You may have native code in your application, so it's a difficulty because the native code is not displayed right now on the visualization. You can have obfuscated code in Java or in native. You can also have remote servers, meaning that the malware is communicating with a remote server, and then if the remote server is dead, you will not see what is happening when the remote server is up. So these difficulties will prevent the analysis to be done. And from the visualization perspective, the problems or the enhancements we can imagine is the navigation into the code. You have seen that the code is huge. You have a lot of parts in the graph. The graph have many nodes and edges, so it's a difficulty we want to solve. And another perspective is to investigate the protocols. When the malware is communicating with the remote server, the visualization may help to see what is inside the protocol, and it could be very useful to see if the protocol is exchanging orders or keys. So these things have to be added in the future in the visualization of GroDDViewer. So thank you very much for attending this video. And if you have any question, I can answer you offline.